Evaluate the definite integral. And here we have the definite integral from 1 to 0 of 3x squared plus x minus 5. And the first thing that we notice is, wait a second, the bounds are backwards. We should have the smaller value in the lower bound and the larger value in the upper bound. So we need to flip these bounds. So to do that, we know that we need to apply the order of integration property. So by the order of integration property, we know that the integral from 1 to 0 of 3x squared plus x minus 5 dx is equivalent to minus the definite integral from 0 to 1 of 3x squared plus x minus 5 dx. So now everything's all set and we're ready to integrate. So I'm keeping that negative on the outside, so this becomes 3x cubed divided by 3 plus x squared over 2 minus 5x. And we're evaluating from 0 to 1. So we have minus, and we're evaluating at the upper bound first. So this will be 3 times 1 cubed all over 3 plus 1 squared all over 0 minus 5 times 1. And we're subtracting the evaluation at the lower bound. So this is 3 times 0 cubed over 3 plus 0 squared over 2 minus 5 times 0. And so we have lots of nice simplification here. We of course know that 1 cubed is just going to 1. 1 squared also goes to 1. And everything in this lower bound evaluation goes to 0. So this leaves us with minus, we have 3 divided by 3 plus 1/2 minus 5. And let's simplify. So we see 3 divided by 3 again, we know goes to 1. So this leaves us with minus 1 plus 1/2 minus 5. And so I can at least start here by combining these whole numbers, or these integer values, 1 and negative 5. So I have minus a negative 4 plus 1/2. And so to combine with this fraction here, no decimals allowed. We want to make sure that we get a common denominator. So we'll think about 4 as being 4 over 1, and we'll multiply the numerator and denominator by 2. So I have minus, this will be negative 8 plus 1 all over 2. So we have minus a negative 7 divided by 2, and a negative times a negative produces a positive value for a beautiful final answer of 7/2. Woohoo!